Hello guys, I'm going to show this video is about how black holes are very deadly for us. It is beneficial and is very deadly. So let's get started. So first I have to talk about I'm gonna tell you what information is. I think that's you think is a very basic concept. It is basic in everyday language, but when it comes to a black hole, it gets really hard to understand it. So information is just like an arrangement of particles. So if you take like carbon atoms and put it in one way, you get coal, and if you take it and put it another way, you get maybe humans or something like that. That's the information. But what we're looking at is the quantum information. When I say quantum, it means like a really small scale. It's like atoms, but like I think you could say it like it's the next level of atoms. You know how we go microscopic and then there's atoms, and then you could just imagine the next level is quantum. So when we're looking at quantum information, we're looking at like the object spin, the velocity, and that kind of stuff. So a black hole, I mean, if a particle enters a black hole, it's never going to leave. That's defined. So this is called the information paradox. What happens is that the black hole takes in information, and it takes in particles which contain the information, and then those particles never come out actually, and thus the information is lost to us. The black hole doesn't like arrange it. Like, just imagine you have like a shelf of books, right? We and that's just normal a black hole. I mean, it's outside the black hole. But then the black hole takes every single page and it shreds it, and then those books they cannot be identified. It can be like we can't differentiate each book, right? That's basically what a black hole does. It takes everything and makes it the same thing. That's what a black hole does. So how is that dangerous to us? Obviously we can like recreate stuff. So if there's something like really unique, like that a thing that doesn't exist anywhere else in the world, and it gets sucked into a black hole, then that's just bad for us, because after it gets sucked into a black hole, it can never come out. So the first solution to this is that the information is destroyed. It's lost to us. It's irretrievable, and it's forever. We can never go back to the black hole and get it back. The second one is that the information actually is took in, and then the black hole actually forms a baby universe to take all that information in, and after taking in that information, it takes all the information, puts it in the baby universe. We still can't access the information, but it's not destroyed. That's the one thing, but it's not really helpful for us. So just imagine you had a hard drive and then you just kind of like broke it or something. All of the photos are not deleted, but you just can't access it, which is not really helpful for us. The third solution is that just imagine we know that the black hole takes in information and like destroys it later, but what does it do with it in the meantime? So what we're thinking is that the information is actually stored on the black hole surface, and you know how black holes grow, right? So what it does is, after it takes in some mass, it needs to create new space to fit that extra mass. I know the mass is all concentrated at the singularity, but how do the black holes get bigger? By taking in mass. So what we're gonna think is that what it does is that the black hole actually encodes ENCODES. Alright, it encodes the information on its surface, which is why every time it takes in new information, new mass, or like a star or something, it has to grow, or it's not gonna fit. it's just gonna like increase in density. It's already infinite density, and if it increases in density, I don't know what's just gonna happen, but it's not good. That's one thing we know. So that's that the black hole actually encodes that information later on its surface. Later on, it destroys it, which we think would be happening, but actually what happens is that, Hawking radiation, right? It takes some of the black hole's mass and it goes away. I explained in earlier videos. So what it actually does is that the Hawking radiation takes some of that mass, actually takes the mass, and it goes away. And it's just like wandering out. It's not like stored somewhere. It's wandering out, but it's not like irretrievable. We can go and get it. I think it's a little hard to like collect information from such a big space, but still, it's possible. It's not like the baby universe. We can't access it, but the information is still there. We can actually go and actually retrieve it. It's like forgetting your hard drive's password. So you go somewhere and then you say you want to like you do forget password, and then you for a hard drive you go to some place and then you ask them to retrieve all of that. It's gonna cost a lot of money at least, but you still have the information, and thus the information paradox is resolved. I forgot to mention it, but these laws, like the one I told you, that information cannot be destroyed, it has worked for us very, very well, and I think it's one of the basic laws in the universe. Now, if the paradox wasn't solved, we'd have to like move that law and start a lot of those from start. That would be like awfully painful for anyone. Still, that's really a lot of work, and if the paradox hadn't been solved, we would have been in deep trouble.